Welcome back. Bill Witte back with more pre-algebra. Listen, by now, you should have taken your third test or be close to it, okay? If you haven't done so, I'm either going to come to your house or you're in deep doo. Because I got to tell you, we can't postpone the end of this class. You can take tests later and you can catch up with them, but you're all taking this class to take the next class. So you have to take that on time. So that's locked in place. So we can't postpone the end. So you have to catch up if you haven't done so by now. Okay? Okay. If you need help, don't forget, you can go to your old buddy, the homepage, www.montgomerycollege.edu/pre-algebra. Okay? What do we got today?
Stranger from the outside.
You know what? Decimals aren't a stranger. They're the same as fractions. You're naming the same stuff, okay? They're not going to be hard. But let's look at what we covered last time first. Do you remember? Oh no! Let's see what we covered. Okay, first of all, the idea of factors and multiples. Factors. Well, 3 was a factor of 30 because it went into it evenly. It divided into it evenly. 5 was a factor of 30. It went into 30 evenly. What else? 2 is a factor of 30. Okay, get the idea of factors.
Well, isn't that special?
Well, a lot of people confuse that with multiples. A multiple of 30, for instance, is 60, because 30 times 2 is 60, because 30 goes into 60. Another one is 90, okay, a multiple of 30. Or a multiple, 30 times 4, is 120. Now we're going to have way more.
To infinity and beyond.
We have way more multiples, okay? Get the idea of factors and multiples? What's a factor of 45? 3 goes into 45. 5 goes into 45. 15 goes into 45. 45 goes into 45. Okay? Various things. These are the things that go into a number.
Isn't that special?
They're the factors. The numbers that number goes into, 45 is a multiple of 45. Think about that. 90 is a multiple of 45. And what's 45 times 3? 135 is a factor. It is a multiple of 45. So you get the idea, the difference
To infinity and beyond.
between factors and multiples. Now, what do we use that for? Well, we looked at things that had common multiples. For instance, 30 and 45 had a common multiple of 90. Now, you may not remember these as common multiples, because we didn't call them that. We called them common denominators, because we were covering fractions, and they were of great use. Now, how did we find these bad boys? Well, to create one, we broke up the various numbers as far as they would go into their possible primes. Remember, as far as you can break them up. And then we actually constructed an LCD, or a term, that contained absolutely every factor from both sets.
Now look at here.
Let's do one. The LCD, if you would, or least common denominator, of 20 and 15. Well, let's take 20, break them up as far as they'll go. Let's see, pick, I don't know, 4 and 5. And, oh, not as far as he'll go. 4 can get farther. Break him into 2 and 2. Now that's into primes. That's as far as it goes. Now 15, let's break him up. 3 and 5. That's as far as he'll go. Okay, now we had broken both into their product of their primes, if you would, their prime factorizations. And now we're going to construct a least common denominator. It needs a 2. At least, oh, it needs 2 2's, doesn't it? Okay, it needs a 5 to cover everybody. Covering all my bases. Now that's 20. It needs a 3. It needs a 5 in 15, but I already got a 5. So I'm hunky-dunky there, okay?
Oakley dokley doo.
So That, when you multiply them all out, is your least common denominator. You might not have been able to do that one in your head. That's the smallest number that 20 and 15 both go into. You don't think 20 and 15 both go into it? Let's take roll. There's 20. 20 goes into it. 2 times 2 times 5. There's 15. 15 goes into it. 5 times 3. Okay, so they both do go in, and that's the smallest number that they both go into. We want things to be small so that it's easy.
Oh, no!
And that is your least common denominator.
This thing isn't as black as it appeared.
Now, what we use that for is to add fractions. But we didn't need it for when the fractions had the same bottom like these. Remember? 4/3 plus 1/3. Well, that was easy. We just added the tops
Totally.
and got 5/3. So when the denominators are the same, you just add the numerators. Even if it's a letter. 7 over y plus 2 over y, it's the same denominator. Fine. Just add the tops.
Oh, gnarly!
So it was simple when the fractions had the same or like denominators. That was easy. The problem was when they didn't have the same denominators. That's when we needed that least common denominator. You remember what we did with that? Adding two fractions here that have a different denominator? Well, we created equivalent fractions that did have the same denominator. For instance, in this case, the least common denominator would be 6, assuming you knew how to find that. Now we create equivalent fractions. How do we do that? We said, what did I multiply 3 by to get 6? I multiplied them by 2. So 4 is saying, hey, bub, what about me? Give me a 2 as well. How come we could do that? Because 2 over 2 is 1. Okay, you can throw 1 around like cheap meat, remember? Yeah, it's okay, isn't it? Okay, that's why we learned the multiplication property of 1. And 4 times 2 in this case gave you 8. So we had an equivalent fraction, 1, that had your least common denominator. Let's look at the half. Say, what did I multiply 2 by to get 6? Oh, 3. So I multiply 1 by 3. Because 3 over 3 is 1. Okay, everything's hunky-dunky. Okay, 1 times 3 is 3. Now we have two fractions that have the same bottom, and it's easy. Just add the two tops, 8 plus 3, and put it over 6, the least common denominator.
Genius! That's what it is. Sheer genius!
It wasn't so bad. Then we mixed fractions with regular numbers, if you would, whole numbers. Remember that?
It's always best to start at the beginning.
Proper and improper fractions.
I say, old chap.
Proper fractions were fractions that were less than 1. That's the reason for fractions, isn't it? Portions, okay? How were they less than 1? Well, the top was smaller
Jolly good.
or less than the denominator. The numerator was smaller than the bottom. That's a proper fraction. The numerator
Well, this is all very sophisticated.
numerator is smaller than the denominator. Well, what if the numerator is bigger than the denominator? Well, then we're talking about
Hey, join the party!
an improper fraction. That's greater than 1, okay? More than a portion, if you would. How are you going to know the difference? Well, where the top is bigger than the bottom. The numerator, you would say, is bigger than the denominator. Get the idea? The numerator is bigger than the denominator is an improper fraction. Now, what do we use those for? Well, let's go back and forth first. We learned how to write improper fractions as mixed numbers and mixed numbers as improper fractions. Let me remind you how we did it. We wrote improper fractions as mixed numbers by, number 1, we divided the numerator by the denominator, top divided by bottom. Okay, we got an answer, the quotient, okay? And we used that whole number part as the mixed number part. Then we took the remainder and put it over the denominator, and that was the fractional part. For instance, 7/2, this improper fraction, we went 7 divided by 2, got an answer, 3, okay? Well, of course, we still have a remainder, Okay, 3, remainder 1. We took the 3, that was the whole number part. And then we took the remainder, 1, put it over the original denominator.
Cool.
And that's how we changed an improper fraction to a mixed number. Now, to go backwards, writing a mixed number as an improper fraction.
Wait a minute.
The reason we did that, by the way, was to multiply and divide. The reason we wanted it as a mixed number was it was easier to graph, okay? Graph on the number line. The reason we're changing it back to an improper fraction is it's going to be easier to manipulate that way, okay? Now, how did we change it back again? Let's see. Step 1, we took 3.5, okay? We multiplied the whole number part, the 3, by the denominator, the 2, and got an answer. Then we took that answer, added it to the numerator, the 1, okay, and that added it to there and put that over the original denominator, 2. For instance, 3 times 2, I got 6, added that to the original numerator there, to the 1, got a 7, and then took that number and put it over the original denominator. So we just went back 3.5 back to 7/2. So it'll be easier to work with for multiplying and dividing, you may remember. Oh, it's improper.
Whoa! Someone smells stinky! Oh, it's me.
Oh.
How about a little fire, Scarecrow?
Okay, now we needed to know that to multiply these two numbers. Okay, the first thing we did was we changed them to improper fractions. I took 3.5 and changed it. 3 times 2 plus 1 over 2 is 7/2. Took 1 1/3. 1 times 3 plus 1, 4/3. Now I just multiply them regularly. Of course, when I multiply, I always cancel before to make these to make it easier. Let's see. 2 goes into both of these numbers. 2 goes into 2 once, and 2 goes into 4 2 times. And I don't see any other canceling. So we basically just multiply across. 7 times 2 is 14, and 1 times 3 is 3.
You're absolutely correct.
And there's your answer.
Yoink.
Okay, what about dividing mixed numbers? Well, we use the regular rule for dividing, and that was to take the first fraction and multiply by the reciprocal of the second fraction. Remember that? Okay, so we just changed it into a multiplication problem. So for instance, in this problem, here again, all roads meet at improper fractions. Let's change both to an improper fraction. 3.5 becomes 7/2. 3 times 2 plus 1 over 2. And 1 1/3 becomes 4/3. 1 times 3 plus 1 over 3. Okay, now 7/2 divided by 4/3 is going to be the same as 7/2 times, reciprocate the second one, 3/4. Okay? Do we have any canceling we can do here? I don't see any, so we just multiply across. 7 times 3 equals 21, and 2 times 4 equals 8.
Hey, you're plumb right, Farman.
Oh, thank you.
Perhaps I could be of some assistance.
Then, to solve equations that involve fractions, which of course we all hate, we had a real nice tip. And that was
LCD man.
multiply everybody by this magical LCD. Whatever it is, the LCD of everybody involved, in this case. And I'm promising you that if you do that to everybody, you got to be fair, it'll clean up the equation. For instance, let's see the first terms here. 6 and 2 cancel. You're loving that. 2 goes into 2 once and into 6 3 times, so I get a 3x. Here we got cancellation, and we get a 2x. Ooh, it's looking sweet, no fractions. Here I don't have any cancelings, I just multiply. Now I got an equation that I know how to do.
Hey, this is great, man.
Because all the fractions are gone. And that's the way the second line should look. All the fractions should be gone. Now I just solve it normally. Let's see, 3x plus 2x. 5x, and I get x alone. 5 is multiplying, so I'll do the opposite to both sides. Divide by 5, and I got the answer is x is 6/5 in this case.
You're absolutely correct.
So that's a nice little tip. When you have a fractional equation, multiply through by the least common denominator, and you're hunky-da-dunky. It's time for the new stuff today. Remember what it was? What are we going to cover today?
This crowd is going deadly silent. Cinderella story out of nowhere.
Now, decimals are not out of nowhere, okay? They're very much like fractions, okay? And they're also very much like something else you know, whole numbers, okay? And digits. Let's take a look at that. The decimal numbers basically are a whole number, the ones, the tens, the hundreds, and so on, the thousands.
Oh, gnarly!
And these have an additional part, a decimal part. Now, the digits in this case are the tenths, the hundredths, the thousandths, and so on. Okay, so you'll have to know that. They work backwards, kind of, don't they? They get smaller. Now, if you wanted to write decimals, what you would do is write the whole number part, write it in words. Write the whole number part in words. Then we're going to replace the decimal point with the word and. Okay, this isn't a internet address. Okay, we don't say point or dot. We never say point. We actually say the word and. That's what it means. You're putting the whole number together with the decimal number. And then we write the decimal part of the number followed by the rightmost digit title. What do you mean the rightmost digit title? Let me show you. Okay, for instance, this one. 42 and 7/10. I'm going to write it. 42. Replace the decimal with and. Write out the 7. Now, what is that? 7 what's? Well, you need to know your digits. That's tenths. So we say 7 tenths. So this is 42 and 7/10, not 42.7 for crying out loud. Okay, how about this one? Write the whole number, 5. The decimal you don't say point, you say and. Now we write this part, which is 19, but it's 19 what's. Don't ever write what's, by the way. Okay, the last one is the hundredths digit, so we're going to use it's 19 hundredths.
That's the fact, Jeff!
So you always use the last one is the name of that tune. Okay? Got another one. It looks a little harder, but it's not. Do the same thing. Write the whole number, 12. Replace the decimal with and then write the fractional or the decimal part, which in this case is just 2. And then what's the name of the digit? The last digit. Thousandths. So it's 2
You are correct, sir.
thousandths. 12 and 2 thousandths. Okay, so that's how we're going to read or write these for that matter.
And another thing.
Okay, what else do we know about decimals? If we want to write it as a fraction, well, just say it. How would you read that? If I just showed you how to read it, I hope you'd say, well, you could say 0 and, but we don't need to say the 0. So it would be 43 hundredths, because that's the hundredths digit.
Cool.
So that's what we write, 43 100ths. Not so bad. How about this one? Don't you dare say 0.5. I'll smack you. Let's see. We'd say 5. And what digit is that? That's the tenths digit. So we'd say...
Is that your final answer?
Well, you'd say 5/10, but what we'd really do is reduce that as a fraction, because all fractions should be reduced. How do we reduce this bad boy? Well, what are top and bottom both divisible by? 5, so we'll divide by 1 in its fancy form, 5 over 5. And actually, 5/10 as a fraction is 1/2. Well, you never would have guessed that, huh? How about this bad boy? Well, I'd write it the way I'd read it. If you read it properly, you would say 1 and
Yeah, baby. Yeah.
13 1,000ths, okay? And if you needed to reduce it, you would, but we don't need to. So that's your answer. So that's simple. Now, consider something about comparing decimals. The first one here, 3/10, and the second one, 31/100. Which is bigger? You might say the second one's bigger because it has more numbers. Well, that doesn't make sense. Okay, I want to see who's greater. Well, 3/10 is the first one, reading it properly. And I hope you see now I'm trying to show you the importance of reducing. Because while the second one might have looked bigger, if we reduce, dividing top and bottom by 10, otherwise known as 1 on Friday nights, we get 3/10. It's the same. So you always have to reduce. How about the next one? Which is bigger here? Well, that would be written, could be written if you would, 300 1,000ths. Well, we could reduce that bad boy, dividing top and bottom by 100, and we once again would get 3/10. So there again, they're the same, so you'll have to reduce. You might even notice that when the zeros are at the end of a decimal, you really don't even need to write them, do you? Okay, when they're at the end of a decimal, okay?
Pay attention, son. This is for your own good.
Because they really don't make any difference. That's the only time you can take away the zeros is when they're at the end of a decimal. It's a little bit of a shortcut, okay? Okay.
Let's play. Here we go.
Let's compare these two decimals. You're so smart. Well, let's say them. Well, we want to compare apples and oranges here. We want to compare apples and apples. So I don't want to compare tenths to hundredths. So that's not going to help me. So in the same way I can take away zeros, I can add zeros so that I'm comparing apples to apples, if you would, and oranges to oranges. Now, the furthest of the two where I go out here is the hundredths. The first one was tenths, the second one's a hundredths. So I think I'm going to try and have all roads meet at a hundredths. So, let's throw that 0 in there, and I got 50 100ths and 17 100ths.
Survey said.
50 100ths is certainly bigger than 17 100ths. Note, don't get crazy on me here, the mouth's opening to the bigger thing. Don't be worried about greater than sign or less than sign. The mouth opens to the bigger thing. How about these bad boys? Well, let's see. What's the largest, well, I shouldn't say the largest, the furthest I go out with my decimal digits? Well, I'm thinking I'm looking at thousands here, because that 3 goes out to the thousandths place. So I'm going to throw in a 0 so that I'm comparing thousands to thousandths.
Welcome to Fantasy Island.
No, it's really, it's 120 thousandths. Okay, so now 120 more than 103.
Survey said.
So that's the larger decimal. So you get the idea. You can throw in zeros at the beginning or at the end. Okay? I'm sorry, not at the beginning. You can throw in zeros at the end, or you can take them out at the end. Okay, let's do one more, just so you see. Hey, ooh, sometimes you have to throw in more than one. Well, let's see. That's the thousandths digit, and I only have one digit over here. So that I'm comparing apples and apples here. Let's throw in 2. And 100 certainly bigger than 9.
Survey said. So
the 100 1,000ths, known downtown as 1/10, is larger than 9 1,000ths. Okay, and you know another thing we're going to be able to do? We're going to be able to round decimals, just like we rounded regular numbers. Remember how we rounded regular numbers? Take a look at these. For instance, round 568 to the nearest 10. You remember how we did that. We looked at the tens. Okay, you had to know your digits. And everything after that's going to be a 0. So it's either 560 or 570. Now, how did you decide? Oh, yeah, you remember we used the next digit.
Perhaps I could be of some assistance.
So that's the next digit. And if the next digit was more than halfway, what I should say is if it was 0, 1, 2, 3, or 4, we kept it the same. If it was 5, 6, 7, 8, or 9, we went up. Now this one's going to go up.
Go!
So We round to 570 in this case.
Do that again.
Okay, let's do one more. How is it the same? Let's see. We're going to round this number to the nearest 1,000. There's the 1,000. Okay, that means every number after that is going to be a 0. Well, so it's either 267,000 or 268,000. How do we decide? Oh yeah, we use the next digit.
Are you pondering what I'm pondering?
Well, that's not quite all the way there. So I think in this case,
You're way off. I say you're way off.
yeah, we have to use, this time we have to use the 267,000. We don't go up in that case, and you never go down, okay? Well, that was tens and thousands and hundreds. Why should it work any different if we do decimals? Let's take a look.
Oh, let's get ready to rumble.
We're going to round this to the nearest tenth. Well, that means that everything after the 10th digit will be zeros. But remember what I told you. If it's at the end, you don't even need to write it, okay? So we're just going to stop at that point. Let's see. We have to decide, is this going to be 156.8 or 0.9? Same deal. What are we going to use to decide? The next digit.
Perhaps I could be of some assistance.
And he's not quite halfway.
Oh, he got all of that one.
So there it is. The answer is 156.8. Right there. Don't add your zeros. You don't need to, because you could take them away if you wanted to as well. Okay? You want another, huh?
Thank you, sir. May I have another?
You got it, baby. Let's see. We're going to round this to the nearest hundredth. Remember where the hundredths is. That means everything after him is basically going to be gone in this case, okay? Because it's going to be a 0. Okay, so it's either going to be 267.36 or 267.37. You know how we're going to decide.
Are you pondering what I'm pondering?
We look at the next digit, just like before. Now, that's not quite halfway, so we're going to stay right where we're at. And it's 267.36, and we'll live with that. Okay? Okay, now, how we add decimals? It's going to be very much like how we add whole numbers.
It's always best to start at the beginning.
Let's review again the idea of decimal digits, because I think you'll need to know this. We get the whole number part, which is ones, tens, hundreds, thousands, and so on.
Totally.
And then, of course, we have the decimal part. Now, here's the part you might have forgotten. Tenths, hundredths, thousandths, the next one's 10,000ths, and so on. Okay, now why do I tell you that? Because when we're adding whole numbers, remember that we wanted to line things up because we wanted to add apples to apples, not apples to oranges. We wanted ones to ones and tens to tens, etc.
Jolly good.
So, we line up tens to tens and ones to ones. The ones, 3 and 1, make 4. The tens, 2 and 5, make 7. The hundreds, all lined up. Uh-oh, sometimes you have to carry. I put a 2, carry the 1 to the next one, and add all those up. And I got myself an answer. So that's how we added whole numbers. How's that going to be for decimals? Same deal. Line them up. Now we want to line up things that are the same. I'll tell you what's going to make it the easiest. What's the thing that sticks out like a sore thumb is the decimal point. So, and if you line up something that's right, you're going to be okay. So just line up the decimal points, and everything else will line up naturally. See? Line up the decimal points. Let's see. 3 and 2 is the tenths. Tenths to tenths. We get a 5. And we go over to the ones. 4 and 3 is 7. And the tens. 8 and 1 is 9. So it's not so bad, okay? The worst thing that can happen, I'm guessing, if they're of different lengths. But this isn't going to be a problem if you line up the decimal point. Now, 2.3, where are we going to put that 15 and 2/100ths? See, I line up the decimal point. And you're saying, oh, what happens with the 2? Well, once they're lined up, hunky-dunky. It's easy. If you need to,
Now what am I gonna do?
you can throw in a 0 at the end if you really need to, okay? But you didn't have to. Nothing is nothing, okay? So 2 and 0, make 2. 3 and 0, not so bad, is it? Okay, we're just lining them up and adding them up. 2 and 5, 7, and 1 and nothing. And they add up to, it's not that hard, is it?
Brilliance. That's all I can say. Sheer, unadulterated brilliance.
It's not that hard. Well, sometimes you have to carry, okay? But it's the same deal. You still line up those digits, don't you? And how the easiest way to line up the digits is to line up your old buddy, the decimal point. Okay, let's see. 3 and 2, make 5. I didn't see any carry. Oh, here we go. 6 and 6, and just put the 2 and carry the 1. Okay, looks very similar, doesn't it? Everything adds up to 9. I got 92 and 5/10.
You're absolutely correct.
Now, what about this one? Line up the decimal points, no matter what, no matter how long these bad boys are. Line up the decimal points. That's for addition now. Now, if you fill in zeros, if you feel that you need to. In this case, I put a 0 there. 0 plus 8. There's the hundredths. Now, what about the tenths? Same deal you've been doing before. I'm going to have to add them up. They add up to 13. I'll put the 3. Same thing. And then I'll carry the 1. Okay, now, holy goldie, we're going to have a lot of carrying here. 1 and 5, 6, that makes 12. So I put the 2 and I carry the 1. And he has nobody to add to. So that's about the worst that can happen here. I got 12 and 38/100ths. And it's not that hard.
Excuse me, Professor Brainiac.
Well, let's move right to subtraction, because it's very similar. Because you line up those decimals. You got the idea, Buford. Line them up. Okay, now just subtract. 3 minus 2 is 1. 6 minus 6, hey, 0 is an answer. You need to put it, okay? Don't just leave it out. And 7 minus 1 is 6, and there's an answer. 60 and 1/10. Not so bad, is it? I'm trying to think of anything bad that can happen here. How about if they're of different lengths? Same deal. Just line them up. Line up the decimals. See how we did that? Now, how are we going to subtract 8 from, what are we going to subtract 8 from, one might ask? That's okay. Put in your 0. Okay, we still can't go 0 minus 8. Remember what we have to do in this case? You're going to have to borrow. Okay, let's borrow at least 1 from the 4, just 1. Okay, and what you're borrowing there is a 10th. And 10/10, 1/10 becomes 10 hundredths. Okay, so there we have 3/10 left over. And we'll put in the 10 on the hundredths. And now I can subtract 10 minus 8. Get 2. 3 minus 2 for the tenths. 1. And the 6 minus 5 on the ones. And you got yourself an answer. So sometimes you're going to have to carry, but we carry the same way. We carry the same way as we did for whole numbers. So it's not that hard, is it?
And now, ladies and gentlemen, for our next attraction.
Oh, this is really cool. You're going to love this, okay? This is multiplication of decimals. Let's take a look. Now, before we start this, let's review the idea of putting in zeros and taking them out. Remember that this is 3/10, and that's 30/100ths. Of course, if you reduce it, you get 3/10. and they're the same thing. This one is 300 1,000ths. And if you reduce that, you get the same thing. So my point, you remember, is that you could take out zeros that were at the end or put in zeros, we just found out, that were at the end of a decimal. Only at the end, okay?
Pay attention, son. This is
Remember that now, okay? Because when we talk about multiplying,
And another thing.
it's going to come into play. Remember writing a decimal as a fraction. How did you write this? You wrote it the way you said it. It's hundredths out there, so it's 43 100ths. Remember how you said this? Don't say 0.5, you said 5. And what place was it? It was the tenths place. You have to know your digits.
Is that your final answer?
Well, okay, it got us started as 5/10, and then we reduced. Always reduce fractions. We reduced and we got 1/2, okay? Even a difficult one like this could be written as a fraction. Well, basically it would be a mixed number. It would be 1 and 13 1,000ths. Now remember that, okay? That's going to come into play as well.
And another thing.
And we got to put it all together. The idea of multiplying fractions is going to come into play because I'll tell you what, we're going to change these to fractions. Remember the rule for multiplying fractions? Multiply the tops and multiply the bottoms. And if you can, reduce. But in this case, we couldn't, so we just got 2 21ths. Okay? Okay, now multiplying decimals. What does all that have to do with multiplying decimals? Well, here's the deal. Note that there are 3 decimals in this. Just note that for just a second. Let's write these as fractions. That's 3/10, and that's 2 100ths. Now, how many decimal places were there? Okay, just remembering. Okay, now we have fraction. Well, we know how to multiply fractions. Reduce if you can, but let's just not do it this time, just to see what happens. 3 times 2, 6. Just for a laugh, what's 10 times 100? 3 zeros. Okay, let's move on. 6 1,000ths. Couldn't that 6 1,000ths be written as a decimal, 6 1,000ths? I could have done that in the first place. So basically, in this situation, I changed them to fractions, got the answer, and then went back, hopefully, to writing them as a decimal, if I could do it.
Well, isn't that special?
And note, this number 3 came up again. 3 decimal places. I had a total of 3 in the question, and now I have 3 in the answer.
Hey, there's something awfully screwy going on around here.
We're going to do it again and see if you can notice a pattern. Okay, 7 100ths and 3 100ths multiplied. Now we got 4 decimal places. Let's write them as fractions. 7 100ths and 3 100ths, as I said, and I'm too lazy to reduce even if I could. So I'm just going to multiply across. 21. Oh yeah, 4 again. 21 10,000ths. Now how do you write that? 21 10,000ths. Uh-oh, wait a minute. There's that number 4 again.
Wait a minute.
Now you got to notice a pattern. Kumbaya. Let's see. Here's the deal. To multiply decimals, and you can use this all the time, multiply the numbers as if there wasn't a decimal there. You don't even see a decimal. Just multiply them normal schmormal, if you would. Then take that answer, count how many decimal places there are in the total problem, the sum, okay, and move the positioning of the decimal places that many.
Allow me to demonstrate.
Okay, let's take a look. Now, we're going to multiply normally as if there was no decimal place there. Now it's a 34. Okay, and 34 times 2 is 68. Now, it wasn't a 34, it was a 3 4/10. Okay? So we're going to take the result, 68, and we're going to position the decimal point, the number of decimal places equal to the sum in the whole problem. Well, that was easy in this case. There was only one, okay, the 4. So we're going to see only one, move it over one place. It's going to be that much smaller. And the answer is 6.8.
Yes!
That's the deal, Schlemiel.
Do that again.
Okay, get a little harder. Let's take a look at this one. Multiply them as if there was no decimal place. Okay? How do you do that multiplication? Let's do it. 4 times 3. Let's see. 12, carry the 1. 4 times 2 is 8, and 1 is 9. Okay. Now, 1 times 3. 1 times 2. Add up 2. 9 and 3 make 12. Carry the 1. Okay, so we get 322 normally. Now, what do we do with that 322? Well, we count up how many decimal places there are in the whole problem. There's 2 in this case. Well, that's how many we're going to move it over in the result. And the answer is, I don't want to say 3.22, rather I should say 3 22/100. Son of a gun.
Genius! That's what it is. Sheer genius!
It really isn't, because it really isn't that hard, is it? Okay? Just got to remember to move them over, otherwise it's the same stuff. Okay?
Now I say look at here!
Now remember, there's another shortcut I'll lead you to. Remember multiplying by tens, like 5 times 10, we just added a 0. Or 5 times 100, or 3 times 100, we added 2 zeros, right? 12 times 1,000, we add, what do you know what? 3 zeros, okay? Well, notice a pattern. A little bit of a pattern.
Oh, right, guys.
Well, let's put these two shortcuts together. What if I wanted to multiply the number 239 and 452 1,000ths by the number 10? That's a special kind of multiplication. Okay, well, let's add a 0, just like the rule did. Okay. However, remember the other shortcut? We have 3 decimal places, so we have to move the result back 3 places. And we get 2,394 and basically 520 1,000ths, or you could say 52 100ths. Get the idea? Now what happened there? What really happened was I moved it over from its original spot only one place.
What happened?
Get the idea?
Cool.
That's a nice shortcut. What if I want to do the same thing by 100?
Well, doggy.
Well, you could do both shortcuts, add 2 zeros, and then move it back the number of decimal places in the problem, which is 3 in this case, and get an answer. But what is the net result, really? How many places?
Hey, you're plumb right, farmer.
We really only moved it over 2 places. So when you multiply by factors of 10, just count the zeros and move it over that many places. Now that's only for factors of 10.
You are a cool toy.
Yeah, it works. So move the decimal place to the right the same number of places there are zeros in the power of 10. Remember, it makes sense to move to the right because we are getting this thing. It should be larger because you are multiplying by 10. It should be a larger number. If you move to the left, it'd be a smaller number. Okay?
Excuse me, Professor Brainiac.
Okay, how about this bad boy? I'm going to multiply it by 1,000, which means I'm going to end up moving it over 3 places. Right? 3 places to use my shortcut. Uh-oh, I don't have 3 places.
Now what am I gonna do?
Well, remember your old book? You can make another place. Who are you allowed to bring in at the end of a decimal? 0. Okay? You can always bring in 0 and make another digit. And that's your answer. It's a nice shortcut. What if we want to multiply this one by 1,000? Well, we have to move it over how many zeros, or how many spots? 3. Right? 1, 2, 3. I don't have 3 places to move it over. But I'll make one. I'll make 2. I need 2. There you go. And you got yourself an answer. Nice, quick, and sweet. Now, this only works for powers of 10, like 100, 1,000, 10, etc. Okay?
We can't do it. If we keep this speed, we'll blow up any minute.
I'm going to do one more thing today, okay? Since you're doing so well, and it's not that bad, we're going to use the same theories in dividing decimals as we did in multiplying decimals, okay? Let's take a look. Let's remember some of the things about dividing first, okay? What did we cover before? Well, remember the I. I'm going to use some fancy words here, okay? When you have a division problem, the thing getting divided up is the dividend. The thing doing the dividing is the divisor, and the answer is the quotient, okay? Now, it may also look like a fraction. You say the numerator divided by the denominator, but we could also call the numerator the dividend, the denominator the divisor, and the answer, of course, the quotient, okay? Could even look like this, where in this case, the 42 is the dividend, 7's the divisor, the thing doing the dividing, and the answer is always the quotient in a division problem. Now that's of use. Remember how to do long division. You thought we were going to not come back to that. Well, let's do it. Let's see, 3 into 2,541. Remember how we did it? We said, how many times does 3 go into 2? You started with the first digit. Well, it went in nonce. Okay, so we tried the next digit. Or I could put a 0, but I really didn't need to. How about 3 into 25? Now that went in. Okay? It went in 8 times. So I put the 8, and note where I put the 8. Over the 25, not over the 2, because I'm dividing into 25. Okay? Neatness is a factor here. Okay? Okay, so I made my guess. I multiply to see how much my guess is off by. 8 times 3, 24. And how much is it off by? What's the next step? Subtract, and I'm off by 1. Okay? Now, my guess here really, I'm guessing 800, aren't I? So let's make another guess. 3 into, bring down the next digit, and 3 into 14. Let's see. 3 into 14 goes 4 times. I multiply, just like I did before, and I subtract to see what I'm off by. Okay, once again, bring down the next digit, if there is one. Multiply. 3 into 21, nicely goes 7 times. I made a new guess. Multiply. And subtract to see what you're off by. And in this case, hi Mom, I'm not off by anything. Bring down the next digit, and there isn't a next digit, so I'm done. So that was the idea of long division. That's going to be the same deal, if you would, with decimals.
Oh, Magoo, you done it again.
Trust me. Let's take a look.
And another thing.
Oh, one more thing before we talk about dividing decimals. Equivalent fractions. Okay, remember the idea of equivalent fractions. Fractions were equivalent if, like for instance, 1/2 and 2/4 are equivalent if they equal the same amount. These two are equivalent because on the number line, they have the same measurement, okay?
Well, ooh-la-dee-da.
Well, we're going to be working with equivalent fractions because that's what decimals can become.
And another thing.
The other thing about equivalent fractions we knew they were equivalent not just by looking at the number line, but
What happened?
what we really did here was divide, or multiply, by your old buddy 1 in various forms. In this case, in the form 2 over 2.
Well, doggy.
In the top,
Well, doggy.
and in the bottom. That's why we needed to know the multiplication property of 1.
Pay attention, son. This is for your own good.
Well, equivalent quotients are the same thing, because that's what fractions are. Well, if I take 3/5, well, 3/5 is equivalent to 300 500ths, because I can work the other way and multiply by 1 in various forms. And that's going to be the trick we're going to use here with our decimals. We're going to create equivalent numbers and get the answers to something we already know how to do.
Prepare to be astonished.
Okay, here comes dividing decimals. To divide decimals, we're going to position the decimal point. We're going to make things bigger. So we're going to move it to the right so that we're working with whole numbers. Okay? To the divisor. Now you need to know what the divisor is. Okay? You got to take care of the divisor, make it a whole number. Now if you do it to the divisor, the dividend's going to be mad. You also have to do it to the dividend. We just showed you why. Okay? If you do it to the top, you have to do it to the bottom. Or if you do it to the bottom, you have to do it to the top. Okay? And then you'll be fair. And then you just divide numbers the same way you would as whole numbers. So because you've made them whole numbers, and you'll get the same answer. It's not so bad. We turned it into a problem that we know how to do. How are we going to do this? Well, we're going to take that 4/10 and we're going to move the decimal place over to the right. In that case, 1 place. Now, to be fair, I have to move it over in the dividend as well. Let me put it up there before I forget where it goes. Okay, now I just divide as if they're regular numbers. Okay, 4 into 33 goes 8 times. Multiply, subtract, bring down the next number. Okay, 4 into 12 goes 3 times. Multiply, subtract, bring down the next number.
Oh, he got all of that one.
Oh, there isn't a next number, so we've got ourselves an answer. The answer is 8 3/10.
Thank you, sir. May I have another?
Remember the idea here is turn the problem into something you know how to do. Okay, we're going to take that 5/100ths and I'm going to move the decimal place over 2 places, basically multiplying by 100 here. That's where the decimal place will be. Now, if I do it to the 5/100ths, I also have to do it to the dividend to be fair. Okay, so move him over 2 places. And he'll go right there. And just forget him. Now, wait a minute, don't forget him. Put him up where he was, where he'll be. And now we'll divide normally. Okay? Now that 05, if you would, is a 5. So we go 5 into 22, divide normally, 4 times, so we multiply, subtract, and bring down the next number. Okay? 5 into 25 goes 5 times. Multiply, subtract, bring down the next number. Oh, this isn't so bad, is it? Now remember...
Excuse me, Professor Brainiac.
Remember what we did when we multiplied decimals by power of 10? We basically just moved the decimal place, the number of zeros, to the right. Always to the right when we're multiplying because the number was getting bigger. We're going to have the same secret for division, except in dividing, we're going to move to the left because the number is going to get smaller. Let's try one. Now in this multiplication, there's 2 zeros, so I'm going to move that many places to the right. And that's my answer. This is by power of 10 now. I'll play the same game with division.
Code red. Repeat. We are code red.
It's division. I got 2 zeros. So I'm going to move 2 places to the left because it's going to get smaller. And I got that answer. How about this bad boy? This is division.
Oh, right, guys.
So it's going to get smaller. And by how many zeros? 1. So I only move over 1 place. Now this only works with powers of 10. And that's your answer. This one's a multiplication. So it's going to get bigger. Get the idea? By how many places? 3 zeros, so 3 places. There's your answer. Now you didn't have to put the period, or the decimal point, okay? This one's going to get smaller.
Code red. Repeat. We are code red.
This is division by 3 places. And there's your answer.
Yeah, baby. Yeah.
Now what if I don't have those places? This one should get bigger by 2 by 3, but I don't have it, so I have to add 1. So I added 1. Well, this one I'm going to divide.
Code red. Repeat.
Should get smaller by 2. But I don't have 2, so here again, I can add 1. Same deal. And you get yourself an answer. If you need to get 3, you may have to add 2 more. You can do it. Add 2 more, get yourself an answer. Holy goalie, we're done. Okay. You know what it means. It's time for you to go do your homework. Okay? When I say do your homework, I don't mean look at it. Okay? I mean do it. Grab your pencil, pick it up, and do it. Okay? If you get stuck, don't forget, you can always go to the homepage at www.montgomerycollege.edu/pre-algebra, or email me, bwitty@mc.cc.md.us. So till next time, thank you. Thanks for listening. Thank you very much.